So we're going to talk about one of these investigations where it's like blocks that are like the shape is growing in a sort of predictable way, and we have to find an explicit formula where we could jump to, say, the 100th figure and still know or be able to figure out how many boxes there are without having to do all the ones before this. So in another video, I did the algebraic approach, which is somewhat more reliable because it will also work for just basic number patterns, or sometimes if the shape looks a little bit different. For example, there's another one in the same booklet where it's making like a polygon and then it's getting like bigger with different numbers of sides. And this geometric approach that I'm going to show you really will only work if your pictures involve these kind of like stacked blocks. They could be other icons like dots, or I don't know, sometimes they're like whatever icon, but it would need to be able to make these kind of like stacked shapes. So first we have this, which is great. However, anytime that we see stairs, like the shape has stair sides, for example, here, or here we have the stairs, one trick slash the only real trick to be able to do this without you needing to use an algebraic method is to somehow manage to rearrange the stair shapes into a rectangle. So like imagine we've got something that instead looks like this. So it's the same picture, but I've highlighted this left-hand side that's in green. So on like green side, we have sort of the taller stairs, and on the right-hand side, the bluer. It's still stairs, but like they're shorter. They don't go all the way to the top. It can be the case that you have a picture that's only the green shape. And if that's the case, you'll have to double the shape and flip it upside down. But since we also have this blue over here, we're just going to take that blue and flip it upside down and stack it next door. And it's really important that you stack it to the left. So if we see like here were these two blocks, actually let's start at figure 4, it's easier to see. So on figure 4, I have these blue ones. I flipped them over and I brought them over here on the left. So like this stack, you can see where the old line was here. So this used to be blue. It's for counting later that I turned them all orange, although I realize now in this moment it would be helpful if they were still blue. But so they're over here. But super, super important is that you stack it always to the left. If your stairs are like a slightly different shape where somehow there's more space down here or extra blocks, fine, you have to count them separately. The same way I'm going to count these top green leftovers separately. But it always needs to be one column to the left. It's important for the way that the area of the shape works out. So in this case of like the double stairs, we flip it over, we put it on the left-hand side, and this is where we will count from. So as always, we're going to need a table. And this table will always have this first column that is really thin because it just contains the letter N, which represents the figure number. So here I have 4 figures. And then on the right-hand side, I don't really know how much space I'll need, so we just leave it this wide. We can call it whatever we want. I think I was calling these blocks, so I'm just going to call it B. And then because we're doing sequences in class anyway, we're just going to use like the subscript of N. It just means how many blocks are in the nth figure. First figure, you're almost never going to find the pattern from the first figure because it's just like not yet enough information. But so we have 1 green block. Great. Moving on. I already have the green pen selected, so I'm going to do the green first. So for figure 2, I have these 2 green blocks, plus we've got, this is like 2 rows tall and 3 columns wide. So that's 2 times 3 for the number of blocks in the second row. This equals 8, which is great. Like as I mentioned before, this is an important number to have, but rarely are you going to be able to see the pattern in this number. Some people can, and some people will see it, but most people won't. I don't know why I pronounced that weird. And if you're going to justify it, you anyway need all of this working out. So we're still really focusing on the working out. Going to figure 3. So looking first at the green, there are 3 of them. Plus, now we look at the orange. And here, you always need to do this in the same order. So because I put the 2 first, and like that was how tall it is, I again need to go with how tall it is. So that's 1, 2, 3, 4, 5, 6. So 6 by 4. Okay, and then just to like keep it consistent, this is going to total to 27. I'm leaving space here because I think like maybe this is going to get longer. Probably that's wrong. I see now that it's not really getting wider, but I can fix that later. So in the fourth figure, we have these 4 green ones on top. And now, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 2, 3, 4, 5, 5. Okay, 12 times 5 is 60, so that makes 64. And this is all I've got for now. So somehow I have to find a pattern in this. I can look vertically. Like it's fine to look and say like, oh, that gets bigger by 1. Ooh, that pen was way too large. However, what I'm really trying to do is to be able to look at a relationship between this number and all of these ones. Because in the end, I want to be able to say like, how many are in the 42nd picture and just know what values go here without having to calculate all the ones before. So if I see this, I can tell right away, this first one, it's like literally the same. That is the figure number. So let's jump to 42. For example, say I wanted to do 42. I will put this dot 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 to signify that like I skipped a bunch. So I know the first number is 42 because that's always the same. And then we have a plus. Now it's a little unclear because it went from 2 to 6 and then 6 to 12. And usually we start by seeing like what added. So that's plus 4, but that's plus 6. That's not the same number. Probably this is a second difference, which means like the next one would have been plus 8. And in the case of a second difference, we really need to go back and figure out if there's some kind of multiply. This is the key. Some kind of multiplication relationship between this one and this one. But it needs to be the same in every row or predictable. So 2 is the same as 2, okay, 2 times 1. But here we have 3 times, or sorry, 3 and 6. Okay, that's 3 times 2. Here I have 4 and 12. That's 4 times 3. So maybe I actually did need this space. I'm going to slide this over and I'm going to rewrite this. Instead of 2, I'm going to write 2 by 1. Okay, that 3 can go closer. Instead of 6, I'm going to write 3 times 2. I'm putting the figure number first. You need to be consistent. It doesn't matter which one goes first, but in order to see the pattern, it has to be in the same order for each one. So if I'm doing the figure number first, I'm always doing the figure number first. Or if I'm doing whatever multiplies to make it happen, then that's what I'm putting. But so here, it's like it's gonna be 4 times something makes 12, that's a 3. All right, now again, looking for patterns because I don't know yet what I'm like, what is supposed to go here. Okay, well, this is the figure number. We have established those are exactly the same. And this number is just one smaller. So if I was in row 5, it would be 5 and 4. If I was in row 6, it would be 6 and 5. So if I'm on row 42, this is going to be 42 and 41. And the orange number was always one bigger than the figure number. So like this is 2, that's a 3. 3, 4. 4, 5. So 42, this is going to be a 43. And then we can put that in a calculator. I would have to because I don't know what's 41 times 42 times 43 plus 42 again. So give me 1 second. We'll calculate this. 42 plus 42 times 1 times 3. That is enormous, but if my calculator is to be believed, this is 74088. So I kind of have a pattern. Like I could describe it. I could describe this way the blocks are growing. I could describe like, I know this is the figure number, and then it's always like same, one smaller, one bigger. But in the end, if I intend to get a good grade on this type of investigation, I need to do it with variables. Like this has to be n. Well, it could be any variable, but we're choosing n for like nth figure. So using the same ideas, the green one was always the figure number. It's literally the same. Whatever was in the first column, that's what goes here. And then we have a plus. And then again, it was a figure number, so that's still n. And we're multiplying that by the one that's smaller, and then next by the one that's bigger. By that I mean like one number after. Like to get from a number to the next number bigger, you just add 1. Or to get from a number to the next number smaller, you minus 1. These kinds of situations where it's like bigger or smaller by one or two values is always going to be n plus one and minus one, or n plus two and minus two, this kind of relationship. So we do have here a pattern, which is great. We're like a formula. But in the best case, I want to expand these brackets and combine my like terms to have it in the simplest form. So this is going to need to be simplified. I'm going to leave the n hanging out there because first we need to do the multiplication. But here I have three things multiplied together. There's an n multiplied by n minus 1 multiplied by n plus 1. You're allowed to multiply values in any order. You're just multiplying each of them once. But I think my life will be easiest if I put together, if I multiply those two first. So I'm going to leave this n on the outside. And when I multiply these two together, I will have n squared, because it's n times n, plus n. So that's first one. And then negative 1 times n, so minus n. And negative 1 times 1 is minus 1. And I know that like n minus n is nothing. Okay, coming down, I still have this green n just sitting there waiting because the order of operations says I need to do all of my multiplying before we add. So expanding this bracket, now I have n times n squared, which is n cubed. And I have n times negative 1, which is minus n. I should have equal signs here. And then continuing further to simplify, n minus n is nothing. And in the end, I just get the rule that the number of blocks in the nth figure is n cubed. And like that is the end. I have found the formula. I have already justified why it works by doing all of this algebra. Of course, in an investigation, you're also asked to verify, but they'll tell you, like, verify for figure 3 and 4 or whatever. Verify means I need to plug in a value for n, but it needs to be one of these ones I know already. Because then I can see like, oh yeah, my formula does get the same value as when I just counted them or looked at the picture. So if I were trying to justify this using, for example, figure 4, I would say, I'm going to do it over in this empty space over here. I would say let n equal 4. Then the fourth figure would have 4 cubed. That's 64. And I got 64 when I did it the last time. So yes, I have verified that it works for n equals 4. I could also verify that it works for n equals 3. But I can only verify it for ones that I already know the answer to. I can't say like, oh, I'm verifying for figure 42 because I didn't really see this. I didn't draw this. I didn't calculate it by looking at all the previous ones. I was using sort of a pattern that I had already seen. So to verify, it has to be an answer that like you have seen the figure and counted the boxes. And then you can verify that your formula gives you the same answer as you got when you counted them one by one. So that's a much faster and kind of easier way. The downside is it only works when your shape is this sort of like stairs situation. If they give you, I have seen it was like circles in a hexagon, or I saw like polygons with sides growing. In those cases, you can't really do it because they don't stack up this way. And in those cases, you would need to go back to doing the algebraic approach that I talk about in the other video. I think it's potentially worthwhile to learn them both. This one is quite easy. And then also the algebraic as a backup, just because we don't know what kind of situation you're going to be given. We don't know if it's going to be one of these picture ones. We don't know if they're going to just give you like a sequence of numbers. So ideally, you can do both. That would be, yeah. The ideal would be that you can do both methods. And if it happens to be a shape like this that makes a stairs shape, then easy peasy, you can do the quick method. Otherwise, you'll have to do the algebra.